Lecture 4, we'll review the 5 key questions from evolutionary cognitive science. We'll start with an in-depth overview of one of the 5 questions, the question of ontogeny, and we'll consider the example of the development of fear of heights. We'll end with a broad overview of the remaining 4 questions, the questions of phylogeny, proximate and ultimate function, and the question of hardware. To appreciate these 5 questions, we'll apply each question to the psychology of fear. We'll begin with the study of ontogeny or development by looking at the development of fear of heights. Next, we'll turn to the question of phylogeny or evolution and look at phobias as evolved biologically prepared fears. We'll then look at the question of proximate functions by examining xenophobia as fear of outgroups, and then we'll turn to ultimate functions by looking at fear of outgroups as a pathogen prevention mechanism. Finally, we'll look at the question of hardware and consider the biology of fear and chemical treatments of anxiety disorders. We'll start by looking at the question of ontogeny, or the question of development. Ontogeny refers to the course of development, especially of an individual organism. Compared to many species, human infants are born in a relatively underdeveloped state. Moreover, resources for development are precious and scarce. Devoting resources to develop one trait prematurely might preclude these resources from being used later for another trait. While the development of the infant's heart and lungs is crucial for its survival, the development of its capacity for language is not quite so urgent. Thus, it's not surprising to observe in a preterm or premature infant that their early development prioritizes developing vital bodily organs at the expense of cognitive development. And while a delay in cognitive development, such as a delay in language acquisition, might put the child at an early disadvantage, this is a disadvantage from which the child can easily recover, whereas a delay in the development of the child's heart and lungs or other vital organs could have serious repercussions for the child's survival. Let's now turn to the question of development of fear of heights and ask, when is a fear of heights useful? Is the development of fear of heights something that is crucial for survival for a human infant? Or is it something that can develop later on, like the capacity for language? Human infants typically cannot locomote on their own until about 6 to 10 months of age. Thus, it's not clear what use a fear of heights would be in an infant that can't crawl. This simple observation about the delayed onset of self-propelled locomotion in human infants has led developmental psychologists like Joseph Campos to study the development of fear of heights in human infants. Campos designed a series of clever experiments modeled after early research on fear of heights in other species such as cats. Many of these studies were done with an apparatus known as the visual cliff, in which psychologists constructed a laboratory environment consisting of a checkerboard cliff covered with a large sheet of plexiglass. In this image, the child is placed on the shallow side of the visual cliff, while to the left the experimenter observes, while the mother on the deep side of the visual cliff beckons the child to come near. Although the visual cliff looks like an actual cliff, the child cannot possibly fall down into the deep side because it is covered with a large sheet of clear plexiglass. In a classic study of the development of fear of heights in kittens, experimenters Held and Hines used the visual cliff and another unique apparatus known as the kitten carousel. In this apparatus, one kitten is secured inside of a box where it's not able to move, but it's able to observe the surrounding environment. The box is connected to a long pole. At the other end of the pole, a second kitten is connected to a harness. The second kitten is not only able to observe the surroundings, but can move. Because the harness securing the second kitten is connected to the pole, any movement by the second kitten causes the other kitten secured inside the box to also move. Held and Hine later tested these kittens on the visual cliff. Interestingly, kittens that were held passively inside the box inside the kitty carousel displayed no wariness of heights. However, kittens in the harness, whose active movement controlled the kittens in the passive box, these kittens who actively moved in the kitty carousel displayed a clear wariness of heights when exposed to the visual cliff. Inspired by these findings, Joseph Campos conducted a series of studies with the visual cliff to look at the development of fear of heights in human infants.